All right, so going back to like chapter 1, chapter 2, when it said like this number n is 3 times another number w and 40 more, or something like that. Okay, we would change that into an algebraic expression. Remember doing that? Okay, so we had to be able to recognize words like of and is and more and less, and those terms then describe algebraic processes. So we're going to do something very similar here, but now it's going to be adding the idea that now we're going to kind of specify certain situations where we have to read the sentence, read the statement, and identify, okay, what is dependent and what is independent, okay? What objects in the description are causing change in another object, okay? And then that's going to help us write our variables, okay, define our variables, and then we'll go through and write our equations, okay? I think the best way to address these and learn how to do this is through examples, okay, being exposed to examples, and then it becomes the more and more you do, the more comfortable you get with it. But as we go through, this first one's got a lot of like added information, just to remind myself of what to talk about with you guys. You're not going to write all of this stuff every single time for every one of these problems. But we'll just get into this first example. It says you can estimate the temperature by counting the number of chirps of the snowy tree cricket. It says the outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? Kind of a weird situation. I think it's like something that actually like old timers would do is use this. You guys you've been on a thunderstorm and you've seen lightning, and people say, well, now count, and that will tell you then how far away that is in miles, right? And there's a certain like amount of seconds per each mile, that kind of thing. That's really what's going on here. Same idea, okay? Can we use something to kind of give us a good estimate of, in this case, the temperature, okay? So it says identify what is changing, okay? That's what we want to do every single time. What is changing? Which one of those? So there's two things up there. Temperature is one of them, right? And number of chirps by this cricket. Those are the two things that this story is talking about. Which one of those is changing, and then which one of those is the object that creates that change, okay? So basically what we have to do is identify what our dependent and independent variables are, okay? Do you as a counter, as somebody counting these chirps, okay, is there anything that is impacting the cricket from chirping 10 times to 100 times to 40 times? Nothing impacts the cricket's chirps, right? Okay. So does that tell me that my cricket is independent? Does that make sense? Okay. So identify what variable is causing the change. Okay. That's the number of chirps. Okay. What is changing? This is the dependent variable. That's the temperature. That's the thing that we're going to be interested in. It changes, okay, or I can recognize a change in temperature based on how many times this cricket chirps. Okay. It says which one can you determine based off the other through the story. Okay. So your temperature you can determine or you can find based off of how many chirps there are. Does that make sense? So that's what sets up this idea of what is independent and what is dependent. That is by far the hardest part of these types of problems, is determining your independent and dependent variables. Now, the reason we have to do that is because our dependent variable is going to be in our equation all by itself, okay? We're going to write these so that our dependent variable is solved for, okay? So we need to make sure we understand that. So this is what we do. We call this defining variables. Defining variables. You're going to tell everybody what your variables are going to be, and you have total freedom in doing this. You want to use always X and Y, you can do that. You want to use always A and B, you can do that. I like to use, and you'll see this in a lot of math courses, I like to use variables that are representative of the things that are happening in the problem. I like to use T for temperature, and a lot of times, so capital T is predominant for temperature. Lowercase t usually refers to time or applications of time. So we use capital T for temperature. If you wanted to use something else, you could use something else. Okay? But if I use like A for temperature, that's not really descriptive of temperature, right? There's not an A starting that word. Chirps is C for me. Okay? Again, if you wanted to use B or D or F or whatever, you could. It doesn't matter. But I think chirps is appropriate for, or C is appropriate for chirps. Now, two variables that people like to consistently use are X and Y. Why do we like to use X and Y? Because when we graph things, that's the X and that's the Y, right? Which one of these back in beginning of chapter 4, and it's 4.1 and 4.2, which one of these was the dependent, the X or the Y? The Y was dependent. Good. Okay? So if you're going to choose down here, instead of using T and C, you wanted to use X and Y, you can by all means do that. But because Y is your dependent, and in this case T was our dependent, we would have to let Y be the temperature, and we would have to let X then be the number of chirps. Does that kind of make sense? If you were a person using X's and Y's. Okay? If I use T and C, all that means is when I graph this, if I use T and C, all I do is I relabel this axis as the T axis, and I relabel this axis as the C axis, and we're good to go. Okay? But I have to realize, either way I go, if I use X's and Y's or T's and C's, in some application, I have to understand what axis is the dependent variable, what axis is the independent variable, and then how those things relate to my definitions of my variables. Okay. Now that we've decided that, and like I said, I think that's one of the most difficult things to do with this information, or this procedure. We then have to push the wrong button. We then have to reread our statement and start going through and say, okay, how do I adjust one side of my equation, one variable here, either the C or the T? How do I adjust it so that I can create a function that models this rule that's being described here? So this is why it's important to be able to say that T was your dependent variable. Okay. So right here, I think it's a good idea to underline that or circle that was your dependent, and C is your independent. The reason we do that is when we write our equation, your dependent variable is solved for. Because what we want to do is we want to plug in some values for our independent variable and evaluate, and it automatically tell me what the temperature is. Automatically tell me what that dependent variable is. Okay? So T is equal to, so now if I look at this situation, okay, it says the outdoor temperature. And this question's very nice the way it's been worded. The outdoor temperature. Would you agree that that is T? Is. What's the word is mean to us algebraically? Equals. Good. So is equals. Says about 40 more degrees, or 41 more degrees Fahrenheit, more than. So what does that phrase mean? What does more than something mean? I'm plussing, right? I'm adding. Okay? So I'm going to add 40 more, right? Does that make sense? And we'll talk about maybe the different orders you can write this. But now the next phrase says 1/4 the number of chirps. What's the word of mean to us algebraically? Multiply. So the two things I'm multiplying are the things that are stuck together by the word of, right? So the two things I'm multiplying are 1/4, and the other thing is chirps, right? Well, we said chirps was C, so now we've got 1/4 C. 1/4 C. Okay? Now, could I rewrite this way? You can flip-flop those if you want to. I like to write that bottom way just because that's the way my mind kind of is programmed to work. When I see 40 more than 1/4 of C, that's going to tell me I'm starting with 1/4 C, and then I'll add 40 to that, right? Does that kind of make sense? That's the way I think about that more than process. Either way, though, it's fine. Now, if I were to graph that, let's see here, where's my draw tools? There we go. If I were to graph this thing, okay, and we talked about dependent variable being that axis, the vertical axis. The independent is this axis, okay? Now I want to graph this. I want to create some ordered pairs to graph, right? So I'm going to choose the independent variable chirps, and we'll see what that produces me for the temperature. So if I have 0 chirps, what is that amount going to become right there? 0, right? So I have 40 plus 0. What's 40 plus 0? Just my 40, right? Okay, now I'm going to try. So I can choose any chirps I want. But based on that denominator right there, what is the next best C value to choose? 4. Remember choosing every day, choosing multiples of that denominator? So what's 1/4 times 4? I choose 4 right there for C. That turns into 1 right there, right? 1/4 of 4 is 1. So then I have 40 plus 1, right? Let's do one more. If I have 8 here, what's 1/4 times 8? Yeah. I have 8 over 4, which turns into 2. So now I have 40 plus 2, which would be 42, right? What do you see? So this is what's really nice. I asked you to do this on the one question in your homework, or not your homework, your quiz last week, was if you can recognize that this is a pattern, plus 4, and then from 8 to 12 is another plus 4, and then 12 to 16 is another plus 4, right? What are you seeing as the pattern here? Plus 1, plus 1 again. So what's this next one going to be right here that goes with 12? You're going to plus 1, right? Isn't that going to be 43? Isn't the next one going to be 44? Does that kind of make sense? Okay. Now, obviously, you can all, by all means, plug in 12 right here. 1/4 of 12 is 3. 40 plus 3 does give me that 43. But if my goal is just to fill in the table, if I can recognize a pattern early on, and I've got 5, 6, 7 points that I got to fill in, I don't want to substitute 4, 5, 6 times. I want to just use that pattern and replicate it that way. But now if I wanted to graph this, think about this. Okay, chirps isn't too bad. I've got 0 chirps. Maybe I put 4 chirps there. Maybe 8, 12. Get out here to 16. Okay, should I make my y-axis go the same way? If I go up by 4s, will it be a while before I get to 40? That makes sense? So what we talked about the other day was that it probably maybe makes sense to actually start at 40. Okay, I might want to make kind of that break in my graph right there. So I'm going to start at 40. Now look at your t values. What does it make sense to start increasing by?
1.
Yeah, 1. So my next hash mark I make on my y-axis, I'm going to make 41. And then 42, 43, 44. Okay. And now just plot these points. So 0, 40, 4, 41, 8, 42, 12, 43. What kind of graph am I getting here?
Linear.
Good. Okay. So I can connect those with a line. I'm not going to because I'm terrible with graphing or drawing lines with this tablet, but you guys can connect those with that line. And what that's going to do then is, okay, well, that should project out then if I want to think about, okay, what happens if this cricket chirps 200 times, I should be able to determine the temperature, right? Does that make sense? Okay. What if I did this? What if I said the temperature is 48 degrees? Can I do something like that? If the temperature is 48 degrees, can I then solve for how many chirps there's going to be and predict it that way? Does that make sense to everybody? Okay. But this is the purpose of creating this equation, because now we can create this graph and we can then predict things out in the future based off this little amount of data. Okay. Now here's, like, I hope you guys kind of understand this. This scenario, obviously, it's not very accurate, right? It shouldn't go on forever. If that thing chirps like 300, let's go 400 times, then the temperature would be 140 degrees, right? 140 degrees outside, we'll probably have bigger problems to worry about, right? So there will be some point in this thing kind of stops being a very applicable or accurate procedure. And the other thing is, biologically, this is probably a bad question, because what probably makes the crickets more active or less active? Maybe. But in regards to just like, and instead of time periods like that, let's look at longer time periods like months or seasons. Yeah, the temperature probably is actually the thing that makes the more or less chirps, right? Okay. So those are things to think about that are maybe more like non-mathematical aspects of the question. This question here, okay? And here's the thing. Some of these questions, you might be sitting there, man, I'm never going to be counting snowy tree cricket chirps, or I might never be worried about how much garbage is in the landfill, okay? But we can take out these ideas of landfills and chirps and stuff like that, and maybe put in, earned wages and bills that you have to pay, that kind of thing. You can kind of project in savings accounts and checking accounts and that type of stuff. Okay. This example says a landfill has 50,000 tons of waste in it. It says each month it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after M months? Some of your problems, you're going to find out that they tell you what variables to use. And this is something to be very cautious of, especially using Math Excel, especially on the end of course exam. If they tell you you have to use X and Y, obviously you're going to type that into your computer, right? And then the computer is going to grab what you typed in and compare it to what they've got stored in the background. Well, if you've got everything right, but they told you to use X and Y, but you use T and C, it's going to be marked wrong. Does that make sense? Okay? Because it's not seeing those letters match up. On the end of course exam, you could do everything right, okay, with this function. But instead of using M for month, if you used W for some reason, it would be marked wrong. Okay? And you'd be told that you are a bad math student because you just chose a different variable than what they defined for you. Okay? So just be cautious of that. Some problems tell you, some problems don't. I'm going to say on the end of course exam, they're going to tell you. Okay? So after M months, now here's the thing, we have to describe our variables. Okay? So I just used W for waste and M for month. Those are the two things being talked about here, right? You got to go through your problem and decide what is being talked about. Waste and its time period of months. Okay, so those are two things. Now I just have to decide which one's which. Which one's the dependent, which one's the independent. Okay? And we talked about this month is a unit of time, correct? Month is a unit of time. You guys remember talking about time being something that you can never alter? That make sense? Okay. Time is something that we monitor and we watch it and we have clocks and things like of that sort that allow us to kind of keep track of it, but we can't slow it down or speed it up, right? Or stop it. So time, is it independent or is it dependent? Independent, okay? Nothing affects it, right? That's what I was kind of looking for, saying that we can't stop it, can't slow it down, speed it up. Nothing impacts time. So when you see problems that incorporate time as one of your variables, you automatically know that that has to be your independent variable. That means waste is your dependent variable. Okay? Now, why do I think that's important for us to be able to do? Because every single time that we write a function, our dependent variable is going to be isolated all by itself and solved for all by itself. So right here, W is our dependent variable. And we're going to write then W is changing based on how our months change, right? So this, I'm going to show you a kind of a different maybe way of viewing this. In this problem, so the last problem had those, like we could take that highlighted sentence and just left to right say, okay, temperature T is equals 40 more plus that, so 40 and then plus, and then 1/4 of, and write down 1/4 C, right? So it's very linear in the regards of how we read that and what we can then change it to in terms of algebra. I don't think this question is really all that similar in regards to the way it's structured. If you look through that whole sentence or a whole paragraph, the word is doesn't show up at all, okay? So maybe you sort of think, well, there's no equal sign, okay? You can maybe rewrite this so that it does show up that way, okay? But if we don't want to mess with any of that grammar and fixing that, we should still be able to kind of address this, and I think logically, okay? Let's say that in this example, you know, maybe we are new owners of this landfill, and when we took it over at month 0, day number 1, okay, we knew that there was 50,000 tons of waste in it. Would you guys agree with that? No matter what amount of time elapses, we know we at least have 50,000 tons in it. So that's there, right? What are we adding to it every month? 420, right? So we add 420. So that's after 1 month, right? Okay. So let's say, let me write it this way. So this would be after 1 month. Okay. W would equal 500 or 500,000. Sorry, 50,000. Can't read. Plus then 420. That's 1 month, right? What would it be if I add another month? So in the second month, we would be adding not only what we added the first month, but another 420 for the second month. Does that make sense? We okay with that idea? In the third month, how many of these are we going to have? 3. So you have 420 plus 420 plus 420, right? That would be your third month. Fourth month, you have 4 of them, okay? All right. So how are these being written? Okay. This was 420 one time, right? Can this one be rewritten as 420 times 2? Can this one be rewritten as that plus 420 times 3? Does that make sense? Okay, is this next one 50,000 plus 420 times 4? Okay. But what if I tell you then we're interested in M months? M months. What do I change that 1 to, or that 2 to, or that 3 to, or that 4 to? I change to M. So then my formula for W is 50,000 plus 420 times M. Does that kind of make sense? Okay, now what I think would probably be important to do here, if we have, and I'll put this one here that was 0 months. If I were to just evaluate this first one would give me 50,000 tons, right? The second one would be 50,420. This next one would be 50,840. The next one would be, so adding another 420 to that one, I was thinking it'd be 51,260. Okay, and I can keep doing that. I can keep going as many months as I want, but that is one way of us finding out how much is left over or how much is in my landfill, right? Is using this formula. Could I say, let's plug in like 2 here and make sure that that formula produces that number right there? That make sense to everybody? Could I plug in 3 and make sure that that number plugs or forces or produces that number right there? And that could be a guarantee. If you know how to find out how much is going to be in the landfill by what we did in blue, by just looking at, okay, it's the first month, so it's 420. Second month was another 420 and so forth. And then you can determine that through a formula. If your formula produces the same results, then your formula is doing its job. Does that make sense? You've got the right formula. If it doesn't produce the same results that you could find a different way, then your formula needs some correction. That kind of makes sense? Okay. The hope is eventually, guys, obviously we're not going to write all that blue stuff down. Okay. The more of these you see, the better you're going to get, and the quicker. I know right now in your notes, I think it's a good idea to write it all down. But eventually, I think you're going to be able to read the statement and probably get to that almost instantaneously. Okay. You're going to write your variables down, obviously, and then get to that. Okay. If we were using the variables x and y, we would want our waste to be y, and we would want m to be x. Okay. You guys got questions on this? We've got a question here. It starts talking about, I'll just read a question to you first. The constant seating plan is shown. Reserve seating is sold out. Total revenue for ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent the situation. The question is, what is the maximum possible total revenue? Okay. So we want to create a function that tells me what revenue is. This problem's really hard if I don't know what revenue means. Okay. So we have 3 things down here. I got cost, revenue, and profit. And as we move throughout this course and other algebra courses, these 3 things come up a lot. Okay. One of the most applicable uses of algebra to you is through the use of finances. Okay. Every business, every manufacturer, every retail outlet is going to have this type of stuff, these types of functions identified per object that they sell, so that they can project inventories and how much money they've got wrapped up in cost, how much money they can project in revenues, and then ultimately what their profits are going to be. Does that make sense? Okay, so this stuff's important. Cost, what does cost mean? What'd you say, Lizzie? Okay, so it's an amount of money, but I heard amount of money, all the money added up. Well, what do you mean about that money? It's a special type of money.
The money that you were paid.
Okay, so it's the money that you have contributed, right? It's the money that's coming out of your pocket, right? It's a deficit idea, right? Okay, I'm removing. So I want to just write here, cost is amount of resource. I put in parentheses here money. That's what usually the resource that we talk about. The amount of money out of pocket. Okay. Now I use the word resource because it might be, cost could be in terms of time, right? Okay. If I'm going to do a job, there might be, you've heard all the questions like Sally takes 3 hours to rake leaves or something like that. John takes 2 hours. What if they start doing it together? How long is it going to take them? Well, the resource there, the cost, would be their time. Does that make sense? If I'm building trucks, maybe my resource is the amount of steel that I use to build that truck. Okay, it's going to cost me an amount of steel. Revenue usually is referred to in terms of money. It could be, you could talk about other resources, but usually talking about money. Does anybody know what revenue is?
Getting rid of something or redoing something.
That's renovate.
What?
Revenue. We've heard this word before, right?
Yeah.
Okay? And a lot of people want to say that revenue and profit are the same thing. They are drastically different. Revenue, so this is the amount of money out of pocket, was the cost. Revenue is amount of money so it says mong. Money brought in. Okay. What we mean by that, let's say that let's say I'm Ford and I have $50,000 trucks and I sell 5 of them. How much money did I bring in off of those 5 sales? 50,000 times 5, right? $250,000. Okay. If I sold 6 of them, I have $300,000, right? Okay. Now, what I'm looking at there is the amount of money that I generated per each sale, how much money has been brought in. But that's not my profit, right? Because each one of those trucks had a cost to it, correct? So let's say it cost me $30,000 to make a truck, and I sell it for $50,000. So $30,000 is cost, $50,000 is the revenue. How do I determine profit? Okay, so it's how much money I make after I remove the cost from my revenue, right? So it'd be the $20,000 in that situation, right? So the way we describe profit is that it's money brought in, revenue, minus money sent out, which would have been your cost. Okay? Does that make sense to everybody? If we can remember that, okay, it's going to make our lives a lot easier with these types of questions. Here they're asking me revenue. What is the revenue? So something to talk about is that cost and revenue, and even profit, they are functions themselves. Okay? Revenue, think about down here. It says revenue by itself is going to be your general admission tickets plus your reserved admission tickets prices, right? Or the money made off those things. Okay? Here what I've got going on, and this is important, I've just written it right now for the general money, okay, the general seating revenue. But revenue by itself is determined by the price of something times how many of those things you've sold. So if we go back to that truck idea, if the price of my truck is $50,000 and I sell 5 of them, 50,000 times 5 gives me the 250 that I'm looking for. Does that make sense? Okay. So it might make sense up here, guys, to write when you're doing a cost question. Cost numerically is found by taking the price times then the quantity. Same thing for revenue. It's the price of my tickets maybe times the number of tickets that you sell. Why is that important for this question? If my goal is to determine the total number of dollars in regards to revenue, I need to know what am I making off of maybe these red seats right here. Okay? The question says that those red seats were already sold out, right? How many red seats are there? It says there's, and I know it's kind of hard. Maybe on your sheet it's a little bit easier to see. Are those, did it print out very well? That's not too bad. It says 10 rows, 12 seats in each row. 12 times 10 gives me 120 red seats, right? Okay? So you have 120 seats. How much are you going to sell each one of those seats for? 20. Well, careful, the red ones, $25, right? Is that a price times a quantity? Okay with everybody? If I multiply that out, that should give me $3,000. Okay? So I know off the bat, before I do anything, before I investigate this problem any further, I know because my red seats are sold out that this concert or whatever is going to earn me in revenue $3,000. Does that make sense? I know automatically I'm getting $3,000 from this performance. Okay? But now it's going to potentially grow by selling these seats, right? How much does each one of those seats cost? The yellow ones, the general seating. There's 16 by 30 of them, so it's 480 total seats, right? But each one of them costs $10. And I don't know if I'm selling all 480, because that's what the situation says. It will depend on the number of general seating tickets sold. Okay, so we're not sold out yet with those. So when I do this problem, our revenue is capital R. Okay, it says let N be the number of general seating tickets. That's going to be my independent variable. I don't know how many of those I'm going to sell. My dependent variable is going to be my revenue. That's what's changing based on how many I sell, right? If I sell zero of those yellow seats, I know I'm going to make $3,000 based off the red ones being sold out, right? Does that make sense? Okay. If I sell one general admission seat, how much money can I add to this $3,000? Look up at your picture. What does it say? General seating is worth. It's $10, right? So if I sell one, I'm going to add $10. Okay. If I sell two, I'm going to add $20. So can I write it this way? Is 20 the same thing as 10 times 2? What if I sell 3? Will be 3,000 plus 10 plus 10 plus 10. Is that the same thing as 3,000 plus 10 times 3? Does that make sense? So what if I sell in general admission tickets? Want to be 3,000 plus 10 times how many I make or how many I sell? Does that kind of make sense to everybody? So that's my revenue function then for this particular situation. Okay, 3,000 plus 10N. Now, the question was, write the rule, but also tell us what is the maximum profit you can make, revenue you can make. Maximum revenue. How many N seats could I have in my facility? 30 rows of 16 seats, right? That's 480. So that means I can only make, as revenue, 3,000 plus this 10 times 480. Oh, that's right. That's how much money I'm going to make if I sell out the entire facility. Okay. Is this something we can do? Real quick, I got a couple minutes here. Real quick, read this one about the dog kennel. Okay. Now it says that you're using N for days. Okay, days is a time, right? And time is always independent or dependent? Independent. Okay, so then maybe we use, it doesn't tell me what to use for the other variables, so let's say C for cost. Okay, because that's what we're looking for. How much does it cost after a 10-day stay? Okay, so read that statement and see if you come up with a function rule. If you stay 1 day, you have to have a bath, right? That's what it's saying. You stay 1 day, they have to have a bath, so they have a bath for $12, and then you stay for the $15 extra, right? If I stay 2 days, got to have a bath, but then this number is going to grow to 30, so it'd be 15 times 2, right? And that's the number of days, that's N. If I stay 3 days, that number grows to 45, right? Okay, so what's changing here is the 1, the 2, the 3, the number of days, right? So is that my N? Did you guys see, did you come up with cost, or C equals 12 plus 15N? That there? 12 plus 15N? And now can I put N to be 10 in there? And when I put 10 in there, I get, what, 162 bucks? Okay? Whenever you go somewhere, no matter what you're purchasing, okay, you go to a car mechanic, you go to a dog kennel, you're going to ask, what's the estimate for this? Okay, you're going to fix my car, what's the estimate? Well, they'll type in, well, we're approximately it's going to take 10 hours. We'll pay a mechanic at $22 an hour for every one of those hours. Plus we got, like parts and stuff like that, those costs. And they add that in. Does that make sense? Okay? So they're using formulas like this to give you an estimate of how much it's going to cost to fix your car. We okay with that idea? Okay? It allows people to be able to make decisions. Why would you want to know how much it's going to cost you? So whether you have the money or not to make sure that they can fix it, right? Or I go shop somewhere else to see if they can give me a better deal somewhere. Okay? Math Excel homework tonight.
What do you want to say?